Alright, so section A, we've got some systems of equations, and basically they both equal y, so we're going to take the second one and then replace the first y with what it's equal to. And then all we're going to do is get everything on one side, make it equal to 0. We notice it's a quadratic. It's got an a of 1, so we're going to go ahead and factor it. Once we factor, we're going to find out our x's are -2 and -1, and then we're going to plug those back into one of the originals, the line in this case, and find out the y's. In this case, we got to get the y by itself, and then we'll take -2x minus 2 and plug it in place of the first y. We're going to write down the equation. We see it's a quadratic, so we're going to get everything on one side, make it equal to 0. Then once we see that, we see we can factor it. We find the greatest common factor, and then figure out the x's, and then plug those back in to find the y's, and we get the coordinates where these two graphs intersect. Here another one where we have to get the y by itself. Once we find out 4x plus 5 is equal to y, we plug it into the first one. We make it equal to 0, and we end up with a quadratic. We factor it. We get the x's equal to 0. We find out that x is going to be 2, and then y is going to equal 13. That's the one point where those two graphs intersect. And then here, these both equal y. We just make them equal to each other. We've got a resulting quadratic, which we factor, and we're going to find out that we've got two x's. One's -5 and 2. We're going to plug those back in, and we're going to find out that the y's are going to be -8 and 13. Those are the 2 points where these graphs intersect. Now in part B, they want us to find the a or the c using the discriminant. And so we've got to remember that b squared minus 4ac, when it's less than 0, it's got no real roots. When it's equal to 0, it's got 1 root. And when it's greater than 0, it's got 2 roots. So in problem number 1, we've got a, b, and c. We've got 3 squared minus 4 times 5a is going to be greater than 0. That's going to be 9 minus 20a is greater than 0. We subtract 9 on both sides. Divide by -20. Keeping in mind when we divide by negative, we've got to reverse the inequality sign, giving us a is less than 9/20. In number 2, we're going to do the same thing, only there's only 1 root, so we're going to make the discriminant equal to 0. And so now all we've got to do is fill it in and find out what we've got. 2,304 minus 256a. Subtract 2,304 on both sides. Divide by -256. And we're going to find out that a is equal to 9. So let's look at number 3. a, b, c is going to be -6 squared minus 4 times 2c is less than 0 because there's no roots. And then we've got 36 minus 8c is less than 0. Again, we divide both sides by -8, so we have to flip the sign and give us c is greater than 9/2. In number 4, there's 2 roots, so we make the discriminant greater than 0. We figure out that we've got 64 plus 16c greater than 0. We get the c by itself, and we find out that c is going to be greater than 4. All right, let's go to the next one. In part C, we're going to rewrite this in vertex form, and we find turning points, which are the same thing as vertexes, and the range. We're going to use -b over 2a, and we're going to find the y-intercept. So -b over 2a, we find out that the x part of the vertex is -9. We substitute that in, and we find out the y part is going to be 8. And so now we can write the vertex is -9, 8. We look and see a is positive, so we know that it's a minimum. And now we can go ahead and write vertex form. We take the a from the original, and then we'll get this. And then for the range, well, we know that 8 is the lowest, so that means that y is going to be greater than or equal to 8. The y-intercept, we make the x is equal to 0, and it's going to be 0, 170. All right, so we'll do the same thing for number 2. -b over 2a is going to give us an x of -5. The y is going to be 8 when we plug it back in. So now we know our vertex, which is going to be a minimum. We can go ahead and write this in vertex form. We know the range. There's going to be y is greater than or equal to 8 because 8's the smallest y possible. And then we find the y-intercept. In 3, we find the -b over 2a is 3, and the y is going to be -3. The vertex is going to be 3, -3. It's a maximum. We find the vertex form, and then we find the range. -3 is the biggest, so that means all the rest have to be smaller. The y-intercept is going to be 0, -21. And then last but not least, we're going to do the same thing here. We're going to find out that the vertex is going to be 2, 1. It's a minimum. We put it in vertex form like this. We found the range. That's the smallest y. The rest must be bigger. To find the y-intercept, we make all the x's equal to 0. And we're done. Now for part D, we're going to use the quadratic formula. -b plus or minus square root of b squared minus 4ac all over 2a. So we're just going to plug it in, make it equal to 0, establish what a, b, and c are, and then substitute into our formula. And then after this, we're going to simplify what's underneath the radical sign. And we're going to find out we get 180. That will reduce to 36 times 5, so then we can simplify it and get this. These numbers all divide by the same number 2, so then we can divide them by all 2 and get the final answer. In number 2, we just got to straighten this thing out. We do want to make sure that the square guy is positive, so we multiply everything by -1, and then we just substitute it into the formula. Once we get everything substituted in, then we're going to simplify what's under the radical. And in this case, we're going to get a -4, which that's going to be -1 times 4. So that's going to be 2i. These all divide by 2, so we simplify and get an answer of 2 plus or minus I. And then here we've got it already set up, so A, B, and C. We fill in the formula. We figure out what the radical will simplify to is a -31. That's going to be -1 times 31. So then we've got 3 plus or minus I square root of 31. These numbers don't divide, so this is our final answer. And then number 4, we get everything over on one side to try to keep the square guy positive. We substitute into the formula, and we're going to find out that we're going to end up with a radical of square root of 4. So that's going to come out to 10 plus 2 over 12 and 10 minus 2 over 12. And that gives us our 2 answers. All right, let's look at the next one. In E, we've got some quadratics. There are b terms, so we're going to make it equal 0 and try to factor it. So let's go ahead and do that. There's 2 terms. We look for a GCF, 2x. We divide it out. We break each factor apart, make it equal to 0, and then we find our x's. In this one, we got to make it equal to 0. Find the GCF, which is going to be 2. We find out x squared minus 25 can be factored again because it's the difference of 2 squares. And then we find our 2 x's are 5 and -5. We get it equal to 0. We look for a greatest common factor, and then we make each factor equal to 0, giving us 0 and 3/2. And then number 4, there's 2 ways to do this. We could first, we could see there's no b term, so we could go ahead and get the square guy by itself and square root both sides. Or we also could see this is factorable, difference of 2 squares, and so we could factor it, make it equal to 0, and we'd still get +9 and -9. And then in part F, well, we're going to factor here. We're going to make it equal to 0. We get 2k squared plus 3k minus 14. There's no GCF. A is greater than 1, so we use the x factor. We get -28 on the top, so we need 2 numbers to multiply to get -28 and subtract to get 3. We check a few. We find out 4 and 7 are our numbers. This will simplify to -2. Our answer is going to be 2, and then -7/2. They're the opposites of what we see there in the x. All right, number 2, we get it equal to 0. This a is equal to 1, so we can just go ahead and make 2 parentheses with k and k. 2 numbers to multiply to get to 56 and add to get to 15. Well, those are going to be 7 and 8. When we fill them into our factors, we find out that k is going to equal -7 and k is going to equal -8. All right, in this one, we've got no GCF. A is greater than 1, so we use the x factor. -20 on the top, 1 on the bottom. 2 numbers that multiply to get to -20 and subtract to get 1 is 4 and 5. And then all we do is find the opposites of what's underneath the x, and we're done. Here we're going to make it equal to 0, and it's got no GCF, and a is equal to 1, so we go straight to the parentheses, and we find two numbers and multiply to get to 40 and subtract to get 6 are 10 and 4. X is 4, and X is equal to negative 10. All right, let's check the next one. All right, let me apologize in advance. I didn't give you enough room to do this. For vertex, we're going to use negative b over 2a. We're going to find out that it's going to be negative 1. We're going to sub it back in to find the y part. We see that it opens down, and there are no x-intercepts because this guy never touches the x-axis. Now, for number 2, our vertex is going to be negative b over 2a, negative 2. We plug that back in, and we find a negative 1. So there's our vertex. It opens up. The y-intercept is 3. So we get that right there. If we go to find the zeros, well, this is pretty easy to factor because it's going to be x plus 3, x plus 1. Negative 1 and negative 3 are the x-intercepts. And then all we got to do is connect it. And then looking at number 3, this guy opens down. We figure out its vertex is going to be 2, 1. And now we know the y-intercept is negative 3. So we got these points. And if we graph, or if we factor this really quickly, we find out the x-intercepts are going to be 3 and 1. And then in H, we're going to solve these quadratic inequalities. Keep in mind the basic steps are to find the x-intercepts. Then we're going to sketch a quick graph. And then we're going to find out if the inside or the outside is where the answers are by using 0 to check. So anyway, let's go ahead and do this. Our x-intercepts are going to be negative 6 and positive 2. We get our sketch right here. It opens up. 0 is in the middle, so when we plug it in, negative 12 is less than 0. So the answers are definitely in the middle, and then this is the way I tell people. Now for the second one, to find the x-intercepts, I want to multiply everything by negative 1, and then I find out the x-intercepts are going to be 12 and 2. And after I draw my sketch, they're both on one side and it opens down. So 0 is on the outside. So when I plug it in, I find out that the 0 does not make the original equation true. So the outside's not where the answers are. They must be in the inside. And then for number 3, we going to go ahead and factor this. We find out the x-intercepts are going to be negative 4 and positive 1. When we sketch this, it opens up. 0 is in the inside. Negative 12 is not greater. The answers are not in the inside. So then we're going to tell people x is greater than 1 or x is less than negative 4. And then the last one here, it's got a bigger than 1, so we use the x factor. And then we find out that our x-intercepts are going to be negative 7.5 and negative 1. We draw our quick sketch. It's going to open down. X equals 0 is going to be on the outside. When we plug that in, we find out that the 0 makes it true. So that means that the answers are going to be on the outside. And so we've got x is greater than negative 1 or x is less than 7.5. All right, I hope that helped, and thanks for watching.